Alright, hello world, and welcome back to another day of WWDC session watching. And you can already hear my voice is kind of worse than before, and that's probably because I was talking too much the whole week. But anyways, we're going to, I don't have to talk that much, so we're going to watch another session, and in this video it's about Embrace Swift Generics, which I'm looking really forward to. I heard already great things about it. So yeah, let's get this going. And just as a reminder how this works, I'm going to be counting down from 3 so we can click the play button together, and then you can watch alongside me and just see my reactions and see how I'm typing my notes. And at the end, I'm going to go through my notes and summarize what my key takeaways are from this session. And in case you want to skip the watch along, you can of course also just skip to the end of the video and just watch the notes and summary. All right, without further ado, let's prepare everything. Let me turn off the music and show you the second screen so you can see the little thumbnail here, so you can see what I'm currently saying. And I'm counting down. 3, 2, 1, go. Typical animal example, as always, for generics. Easiest one. All right, there we go. Let's turn the music back on and let's get through the notes here. And here we go. So I would say the session started quite basic. So it started with really basics, starting with classes and things like that. And the beginning was more or less a summary of how you can reuse code, basically, so you don't have like repeated code. And they started with the tip that you should always start modeling your classes with concrete types. So you shouldn't, like if you want to write a generic even, start with a concrete type first, and then write another concrete type, and then you'll see like what they have in common. Then you immediately know what you need to generalize, basically. And I think that's a pretty good tip. That's also how I'm always doing it. Then you should identify common capabilities. So you should think to yourself, like, what is really the same thing? And then they went on to talk about polymorphism and things like that, throwing around some words that I think for people who really care about those things, it's really important to differentiate them. But I think for us, the practical side, or for me at least, the practical side is more important. And they went on to say basically why classes aren't that great. So you can technically have a function and then just override it, but then you need to use a reference type, which is not very efficient. Then it requires the method to be implemented in the base class, and then it's easy to forget to override it, so the compiler can't help you to actually override it. That's also not great. And yes, a couple of other things. And basically they went on to say you shouldn't use classes for generalizing, you should use protocols, and Swift is a protocol-oriented programming language for a reason. So they said think about the common capabilities to put it into a protocol, and that also simplifies, like if you have to write a specific generic type on a class, it's really like you always have to specify it in the class when you have a subclass. For example, for animals, you have a subclass that's called, I don't know, pig or something like that. You need to write feed type or food type or something like that. And that they say basically that's not basically at the core of the object maybe, and then it doesn't make sense to really mention that. So on the type level. That's why in protocols you can use associated types, or they're no longer in the type level, the generics. And also they can be inferred. So for example, when you write something like this, and then you provide a concrete type when you use this method, like a method feed, and then you provide a concrete, I don't know, type that is here in your implementation, a dog, for example, then you don't need to specify associated type is dog. And if the compiler will be able to infer this from your function usage. So you just write less boilerplate code also. New in Swift, you no longer have to write where a dot colon animal. Instead, you can just use the sum keyword. So that's pretty much the same thing. And I would also personally recommend just to use sum. Everybody who's been using Swift UI should know sum already. So like you always have to return some view, right? And now we can also use it here as parameters in Swift 5.7 onwards. So not currently possible, but will be possible. And they said sum indicates that it's a specific type that you're working and that you're expecting to work with. So anytime you use sum, on the usage side, it has to be a concrete type. And that's really important to understand, because that's the difference to an any. If you have an any, even on the call side, you can still have like a variable kind of unconcrete type that just conforms to animal. But if you use sum, when you call it, it has to be a specific type. And yeah, they went on to say basically that you can have them on the parameter side or on the result side, and there's some differences between those. What's important? You can see here, for example, if you provide a var animal and then you initialize it with horse, you no longer can assign a chicken. For this kind of thing, you need to use the any type, the any keyword. With any, it works. With some, it doesn't work. And that's basically the difference between the two. That any accepts differing types, whereas some, as soon as you specify a specific type, it is the concrete type. It's like if this was horse in this code. Yeah. All right. One really nice tip that I personally didn't know also that they gave was that if you have a situation like this and think that this view builder thing is not there, so you just have this function as returning a sum view, and you have a condition like if this is true, then return a farm view, otherwise return an empty view. This wouldn't compile. You would get an error because sum, as I said, requires you to have a concrete type, and it wouldn't know, is it a farmed view or is it an empty view? It has to be clear, and it's not clear. It can be both, right? And you can fix this by just specifying add view builder, and that's a really good tip because yeah, you might run into this, and then you can just specify add view builder. Also interesting was that they used the type of animal to get access to the associated type here and then call something on it. So that's also something you might need if you're using protocol-oriented programming. And lastly, they explained any by already covered any, basically how you can use it. So for example, if you want to feed all kinds of animals, you can't say some animal here because some animal would accept only one concrete type, but you can say any animal, and then you have an array of any animals like this, and then it works. You just have to make sure that when you call methods inside, you can't call a method with a concrete type. You have to call methods that are either any or, and that's a new feature in Swift 5.7 as well, you can also call methods that accept a sum animal. Swift will do the magic then to make sure that types fit each other. And that's it basically. So they went on a lot of talking about any versus sum. So if you really want to know details, you can watch definitely if you haven't watched. Otherwise, this is my summary of Embrace Swift Generics. And as always, we're going to have a quick break. And if you're watching this on YouTube, don't forget to like this video right now. And if you haven't subscribed yet, make sure to subscribe to see more videos like this. And I'm planning to do more interesting videos also that are more cut in the future. And next up, we're going to watch Create Swift Package Plugins. So stay with me here on Twitch if you want to watch that. And I'll be back in a couple of minutes. So see you in a couple of minutes.